Assalamualaikum, my name is Muhammad HAKIMI and this is the introduction for Lab 3. So the voltage drop, line losses and transmission efficiency are all critical factors to consider while designing and operating a transmission line. The transmission line constant of resistor, R, inductor and capacitors have a significant impact on voltage drop, line losses and transmission efficiency. R, L and C are three constants that are spread uniformly along the length of transmission line. The series impedance is formed by the resistance and inductance between conductor in a one-phase line. The capacitance between conductors in a three-phase line form a shunt channel that runs the length of the line. Resistance of transmission line conductors is the most important cause of power loss in the line and dictates transmission efficiency. Short, medium and long transmission line are the three types of transmission lines. The series impedance is formed by the resistance and inductance between conductors in a one-phase line. And the capacitance between conductors in a three-phase line form a shunt channel that runs the length of the line. The resistance of transmission line conductors is the most important cause of power loss in the line and dictates transmission efficiency. Short, medium and long transmission lines are the three types of transmission line. That's all from me. Thank you.
My name is Mohamad IRFAN ROSDI and my text number is CE200103. Now I would like to share and discuss about my simulation and calculation for lab transmission line. Based on the data provided in exercise 1, we will compare the data provided by manual calculation with the data provided by MATLAB simulation by creating a table of value. The table above summarizes manual calculation result to MATLAB simulation value. So, the result of both analyses are practically identical when referring to the data in the table. There is therefore a slight difference between MATLAB simulation and manual calculation. In the MATLAB simulation, for example, voltage regulation is 1.3645%, but for manual calculation is 30.6%. To achieve the same result, set the MATLAB simulation coding to voltage regulation and multiply by 100 to get 30.6%, and the other value is almost the same for both technique, and it can be used. So I think that's all for me.
Assalamualaikum warahmatullahi wabarakatuh. My name is MOHAMMAD NADZRUDDIN, and today I will show the simulation for question for our question 1 for our last lab session, which is short transmission line. So this is the coding. You can see and you can get this coding from the lab sheet. And for the first line is we include the VRLL and the value is 220, and VR equal to VRLL square root of 3. This is the which is formula for VR, and so on. The Z is 0.15 plus J divided conjugate with 2 pi 60 and multiplied by 1.3263 exponent power of negative 3, and then all of this is need to multiply by 40, and this is the first display, and the display is for 0.8 power of factor lagging. So, and this all of this is the formula for the short transmission line question. So after we write the coding, so we need to run the project. So we need to run the coding, and then it will appear the answer on command window. So we can see the display for A. VSLL is 250.0.0186, and for SS this is the the value, REG, this is the value, and EFF. And then for question B, and 0.8 power factor reading, so the value of BSLL is 210.2884, and SS, this value, REG, this value, and EFF for this value. So that's all for short transmission line question number 1. Okay, thank you.
Hi and Assalamualaikum. My name Muhammad AMIRUL by ROFLI. My message number CE2001149. Okay, for the PS3 online modeling of transmission, I do exercise medium transmission line. This question and have some program and this program and manual calculation. So I do to the run and on MATLAB. So I write this back formula into the MATLAB. So I detect some MATLAB detect some error cannot run because on this we declare FPF. So at the bottom on the vsauce vs it write a ph, so I change it into the pf. So all the ph I change to the pf and some formula is wrong, so I multiply it like this. A multiply by vr multiply by ph and this also. So after that I run the MATLAB, so get into the length of line in kilometer, receiving voltage V, power W, power vector L and R and C with per kilometer. So I write the input from the question. So for the line is 200. Okay, for the receiving voltage 1322. So for the power factor 0.8. For the L 0.00149, and for the R 81, and the last is T 0. So after I write this input based on the question, so I run I enter that. So we get generalized ABCD content. So this is we get the answer. Standing and voltage Vs is 1114.575596, and the standing and current is 267.174487, and the efficiency is 49.989059. So this is we can generalize the answer same as, so we must approve we are on the manual calculation. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZAMUDDIN bin HASANAL. I will do the simulation for exercise 3, Y bus matrix. Okay. From the lab sheet, we put the coding into the MATLAB and we just run, and the command window will show us number of buses. So we put three bus, enter, and we put impedance is first 3. Enter the bus number, we put bus 1, and the receiving bus number 2. And now enter impedance bus 1 to 0.1 plus 0.3 I. Enter line charging admittance, we put 0.02 I. Now we enter the starting bus number 2 and receiving is 3. Now the enter impedance of bus, we put 0.15 plus 0.5 I. enter the line admittance 0.0125 I, and the starting bus from 3 and receiving bus number 1, and intermittence 0.2 plus 0.6 I, and enter the line charging admittance 0.028 I. So this is the answer. That's all for me. Thank you.